Because they're dealing with forwarding IP packets, most routers and firewalls support the feature of network address translation, or as its friends call it, NAT. In this nugget, I'd like to chat with you about some terms and concepts and demystify a few aspects regarding NAT in preparation for implementing it on the firepower. Let's begin. And so to start, let's talk about NAT and the actual acronym. It stands for Network Address Translation. We're talking about swapping out IP information inside of IP packets, packet by packet, as they're being sent. Now, a great question would be, Keith, why are we swapping out IP addresses? Well, for one reason, we have a lot of RFC 1918 private addresses, like the 10 network and the 172.16 through 31 network and the 192.168 networks. And with those private address spaces like this network right here, if we try to send a packet over the internet and it's using a source or a destination address that's a private address, the internet service providers, they will drop that and they won't forward it. So if we want to have Bob or Sally or some other user on our network who's using a private IP address be able to communicate to servers and across the internet, we need at some point before it reaches the internet to swap out that IP address. And that's what we're doing with the translation. We're swapping out or changing or replacing the real IP address that's being used on a computer with one that's usable in the network, specifically on the internet, if Lois, this user right here, is trying to go out to the internet. So if we configure a network address translation policy for our firewall and we tell it to do translation, then it'll follow that policy and those rules, and it will simply swap out the appropriate IP addresses every time it sees it. So our policy may say something like this: any traffic that's coming from the inside network, and we can make an object that represents that 10.1.0.0 network. And if that traffic is going out the outside interface or out an interface in the outside zone, and all those options are available, by the way, in our policy, then we want to go ahead and swap out the source IP of Lois, which is 10.1.0.10, and replace it with an IP address that's routable on the internet. Then after the translation of Lois's source address, as that packet reaches its destination and then reply traffic comes back, the firewall who did the original natting is going to do the unnatting or the untranslation of that packet so that it can forward its way back to Lois. So let's talk about some terms here. The real address is the address that's actually configured on a device. So in Lois's case, if this is her computer at 10.1.0.10, if we looked at the configuration of that computer, that would be the IP address that she has associated with her network interface card. So real means the actual address before it's been manipulated or translated. So as part of this rule, when Lois is sending traffic out her address of 10.1.0.10, let's imagine that it's swapped out for 23.1.2.50. or some other address that's associated with this interface here on the firewall. This globally routable address that we're translating to in this example would be the mapped address. It's the address that behind the scenes is representing that address on Lois's computer. Now another question is, when does that mapping happen on the firewall? Is it hard-coded so that every time Lois goes out, she's always going to get that same IP address? Or is it just based on this rule, whenever the firewall sees traffic from Lois, it's going to dynamically create the translation for Lois and then have her traffic go out? If it's dynamically created based on the traffic flow and the firewall seeing the packets and the firewall seeing the policy and then implementing the translation, that's referred to as dynamic. And that's what dynamic represents. It's being created on the fly, just in time, when it's needed. It's not hard-coded, statically there all the time. It's just created on demand when needed. And the flip side of that is, if Lois's computer always needed to be mapped to a specific IP address, we could have a rule that says, okay, if the source address is Lois and she's going out, go ahead and map it to a specific IP address. We'll go ahead and use this one. Once a static translation is created, it is sitting there whether or not Lois sends any packets. And that's an example of a static network address translation rule or policy. Now let's imagine on the inside network here that we have 15 users. And let's also imagine that we have a pool of 15 globally routable IPs that we can use for the internet. Now that's not very likely to have 15 allocated IP addresses that individual users are getting, but if we did, and we wanted to have these 15 users each get one of these respective 15 IP addresses, that's an example of network address translation. It's often referred to as a 1-to-1 mapping. And if we didn't care which user got which address, we just put all these IP addresses in a pool, and then as those users go out, dynamically, the firewall would assign an IP address to a specific IP address on the inside and do the translation. That would be an example of dynamic NAT, with a one-to-one relationship with one IP on the inside going to a unique IP address on the outside. But the problem with that is that we don't have hundreds and hundreds of globally routable IP addresses to give to every single individual user on the inside. So often what we're going to do is we are going to overload and put a whole bunch of users, maybe these 15 users, on one IP. And the question may come up, well, Keith, if I've got 15 users and they all appear as their own internal IP addresses and they all get mapped to .50 as an example, on the way out, when the replies come back in, how is the NAT device going to know which original client to send that to? And the answer is ports. So it's going to track all the ports involved and manipulate the ports involved so that every one of those is unique using unique ports. And then the firewall is keeping track of all those ports, and when the replies come in, the firewall will untranslate those to the correct of those 15 users to make sure all the right packets get back to the original correct sources. And that is referred to as PAT. And if it's dynamically done, that would be referred to as dynamic PAT. There's also the ability to do static PAT, and one of those reasons would be this. Let's imagine we have two servers on our DMZ, and we want to allow users on the internet to reach them. Maybe one's running FTP and the other is running HTTP. And we want to go ahead and map a single IP address out here publicly. And if we have a single IP address, what we could do is we could map one port, the port for FTP, perhaps 21, the control channel for FTP. We could map that specific port to this server, we'll call it server A, and if traffic comes into TCP port 80, we can map that to the IP address of host B or server B. And that's an example of static PAT with one single IP address with the ports hard-coded, so when the appropriate port on that IP address is hit, the traffic is then forwarded to the appropriate internal server. And to finish this up, let's take a look at the concepts of source or destination network address translation. Basically, the greatest way to think about that with source or destination is to think about the initial translation of a packet. What do you mean, Keith, the initial translation of a packet? Well, let's imagine Lois. If Lois just powers on her PC and she's going out to the internet, the initial translation of her traffic is going to be translating her source IP address from 10.1.0 to 10 into a globally routable address. And so for the initial translation, we're translating or swapping out her source address. That, my friend, is source address translation. The initial flow is swapping out the source address. And then when the reply comes back, the response would be untranslated and forwarded back to Lois. And let's compare that to a user on the internet like Bob. And let's say Bob is going to one of our servers. So Bob wakes up one day and says, I'm going to go to one of the servers. And so he goes to a globally routable IP address that we're using as a mapping for one of our internal servers. And when he hits that server, let's imagine it's 23.1.2.50. So he goes to that IP address. In the background, he'd be using DNS. So he would go to DNS for a query, find out what the IP address is, then he would send packets to that IP address. The NAT device is going to swap out the destination address on that initial flow, and it's going to put in the IP address of server A, so that traffic can be forwarded to server A. So on the initial flow of traffic, we're swapping out, in this case, the destination IP address from this mapped address that Bob was trying to reach to the real address that's on the public-facing server. And so that's an example of destination NAT. Just think of the initial flow. On the initial flow of packets, the first packet through the NAT device, what are we swapping out? Are we swapping out the source, like Lois, or are we swapping out the destination, like Bob trying to get to the server? And then to wrap up this discussion, let's talk about identity NAT. This used to be called on the ASAs NAT 0, which basically means it's a rule that we can put in that says, don't translate. That's all it is. So if we have a server here, and let me clean up the screen. If we have a server here, and that server's address is 23.1.2.40, and we want this server to appear as 23.1.2.40 on the other side of the appliance, what we're going to do is we're going to set up identity NAT. And it basically says, I want to map this IP address that's on this part of the network to this IP address, the same exact IP address on the other side of the NAT device. And it's set up as a rule so that the same address can be used on both sides. Now, the great news is that all of these NAT and PAT options are available on the Firepower appliance. Now, there's a good chance that we won't be using every possible option in a production environment, but knowing those options are there is handy. So in the next video, we'll take a look at the logic as far as how those policies for NAT can be implemented on the firepower, and then we'll follow it up with a couple additional demonstrations so you can get the hang of it and get a good feeling for how to implement the policies that you need to regarding NAT on the firepower appliance. So I'll see you in those next few videos as part of this skill. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.